going to solve Project Euler problem 43. In this problem, we need to investigate the 0 to 9 pendigital numbers, which are numbers that are made up of each of the digits 1 to 9 in some order. And well, some of these numbers have the property that substrings of length 3 are divisible by certain primes. So for example, the substring starting at digit 2 and ending in digit 4 is divisible by 2, the one starting at 3 is divisible by 3, and so on, up to the one starting at digit 8, which is divisible by 17. We need to sum all the pendigital numbers with this property. So let's go ahead and write a function that will check this. So we are going to do the following. We are considering the permutations of 0 to 9, which will give us all the 0 through 9 pendigital numbers, and we will check for each of those permutations if they have this property of substring divisibility. So let's start with this substring divisibility. And well, we are going to have these numbers in the form of digit lists, so list of integers, so to speak, just because we can work easier with that, and we call this number. And well, now what do we actually need to do here? We need to check for all the permutations, for all the substrings we're interested in, that this property holds. So I'm going to use all, and then I will leave the predicate blank for a second, and then we can take a second to well, actually take a look at the list we are going to be working with. So obviously we are interested in the substrings that start from 2 up to the substrings that start at digit 8. Now lists in Haskell are indexed starting at 0, so we actually need to iterate over 1 to 7. And we need to check if they are divisible by the prime. So I'm going to define primes, a list of int, and we are only interested in the following ones: 2, 3, 5, 7, 11, 13, and 17. And we are going to zip these two lists together. Now our predicate that we apply is the following one. For each pair of, well, first index of digit in the substring of the number, which I call n, and prime p, we are going to need the 3-digit substring that starts at n. So that can be achieved by having, well, first of all we are going to drop n from the number, and then take 3. And well, this will give us a list with 3 digits. We need to convert this list into, well, an actual integer so that we can check divisibility by the prime. I'm going to write a function list to int. This will take a list of digits and return an integer. And we can just write this in a very general way by doing fold L and going from left to right, so to speak, in the digit list. For each, well, new digit x, we are going to have our value multiplied by 10, and at this digit, well, at the rightmost place, so to speak. Now we're going to convert our 3-digit substring into this, into an actual integer, and then, well, we just check if it is divisible by p. This can be done by calculating modulo p and checking if it's equal to 0. Alright, so now we have a function that will take a permutation of 0 through 9 and check if it has this property. We're going to need to have all the permutations of 0 up to 9. The way to do this is by using the permutations function from 0 to 9, and this of course is defined in data.list. Alright. Now with these permutations, for each permutation we're going to check if it's, well, if it has this property, so we're going to apply filter and substring divisibility, that's our predicate. Now, well, we are basically left with each of these permutations that has this property, but we want to have it as not as a list of digits, but as an actual integer. So we can just apply map list to int, which will do this for us. Then sum them all up and print the result. Now let's go ahead and compile this. And run it with time. And as you see, this gives us the correct answer in 0.33 seconds. Thanks for watching.